This is a pulse amplitude modulation design in Simulink. First of all, let's see the parameter and function of each block. Okay, we have a sine wave. Sine type we use time base. Time we use simulation time. Amplitude 5. Frequency 1 radian per second. Okay, next we have pulse generator. Time pulse type time base. Time we use simulation time. Amplitude 1, period is 0.2 second, pulse is 20%. Okay, the function of pulse generator is generate square wave, pulse at regular interval. Okay, next we have product. Product is used to multiply two inputs that have the same dimension. Next we have sample and hold. Okay, sample and hold, we set sample time 0.001. Initial condition is 0. Okay, function of sample and hold is to take sample of its input signal and hold this sample in its output for some period of time. Okay, next we have analog filter design. Design method we set Butterworth. Filter type low pass. Filter order is 30. Pass band each frequency is 25 radian per second. Next we have scope. Scope is used to display the time domain signal. Okay, let's see the sine wave and the output of pulse amplitude modulation. Okay, first of all we have message signal. Message signal is sine wave. We have carrier signal. Carrier signal in square wave. Okay. Okay. We need to measure pump signal. Okay. Pump signal is generated from the pure sine wave. From the pure sine wave as a modulating signal, and the square wave produce the carrier pulse. So that's happened. Pump signal. For the demodulation of pump signal, we get same as the message signal. Okay, as the conclusion, we can say the carrier amplitude value will not change anything of pulse amplitude modulation signal, whether the carrier frequency is higher or lower compared to the message signal. It can all be observed that the amplitude of message signal is different with the pulse amplitude modulated signal, but it has the same frequency value as the carrier signal.
Pulse amplitude modulation using coding. Firstly, carrier signal and modulating signal needs to be established. So here for FC we'll be using 20 kHz, and then for FM we'll be using 1 kHz. Next, the sampling frequency used is denoted as 100 samples out of carrier frequency, and then the values are converted into period T, which I explained this line over here, and then followed by the general equation for the modulating signal would be cos 2 pi fmt, and then this line here, ct, actually represents the pulse signal, where square function is used to generate a pulse with assigned carrier frequency. So the usage of square function here generates a pulse from negative voltage to positive voltage. So in order to generate DC pulse, first the equation is multiplied with 0.5 volt, which is here, and then which results in the DC pulse peak to peak being negative 0.5 to positive 0.5. It is then added with positive 0.5 here to ensure that the DC pulse generated is only on the positive side of y-axis. So the modulating technique used is basically just multiplying message signal with the square signal. then all of the signal will be plotted. And then as for the modulating process, the modulated signal is then multiplied with pulse signal, and it is passed through the filter, low pass filter. The signal is then convoluted and then produce back the original signal. So the result of FC being 20 kHz and F1 being 1 kHz, it will produce a waveform like this where there is no distortion found. But theoretically, it is said that when FC value is closer to F1 value, there will be distortion occur. So to see the distortion, we can adjust the FC value nearer to F1 value. Here we can see that there is distortion occurred in the signal produced when FC value is nearer to F1 value.
Next, I will talk about the advantage and disadvantage of pulse amplitude modulations (PAM). Firstly, the advantages are the generation and detections for PAM is simple. Next, both modulations and demodulations approaches have a basic technique or methodology. Other than that, pulse amplitude modulations both transmissions and receiving do not necessitate complicated circuitry. And lastly, the advantages of pulse amplitude modulation is it can generate various pulse modulation signals while also transmitting the message or information. So the disadvantages are first, noise cannot be easily removed since it affects the amplitude which conveys information. Next, the transmission's bandwidth is very large. Besides that, the levels of noise interference is higher. And finally, the amount of power required for transmissions is higher. Next, the applications of pulse amplitude modulations. First, applications of PAM is Ethernet. Some types of the Ethernet communication standards are examples of pulse amplitude modulations. Ethernet, which uses Tomlinson's Harashima's pre-coded versions. And examples THP of pulse amplitude modulations with 16 discrete levels, which is encoded in two-dimensional checkpoint pattern known as DSQ128. Next applications are electronics drivers for LED lighting. PAM has also been designed for the control of light emitting diodes, also known as LED. Especially for lighting applications, drivers of LEDs based on the PAM techniques offer enhanced energy efficiency over the system, which are based on other common driver modulation techniques like PWM. The next applications is photobiology. PAM is also used for the study of photosynthesis using a special instrument that also has a spectrophotometric measurements of the fluorescence rise, kinetics, and decay in the antenna for light harvesting. Lastly, the applications of PAM is digital televisions. Ideally, the American Advanced Television System Committee standards for television uses PAM technique to broadcast the data which generates the television signal. The This system is basically on a 3-level PAM but uses some additional processing to suppress one sideband and so makes more efficient use of limited bandwidth.